Now, it has two different parts to it that we're going to look at. The first part of an expression are what are called terms. Okay, now, if you look at this expression, 3x squared minus 5y plus 2xy minus x minus 7, you'll notice there are 5 things being added together. Right? And subtract is just adding a negative. So if you have a subtract, that's still being combined. That's what we refer to as the terms. All right, the terms of an expression are the things that are being added together. So they're combined with add or subtract. So here I've got 5. If one of the terms has at least one variable in it, that is called a variable term. And it doesn't matter how many variables it has. If it has even one, it's a variable term. A term that has no variables is called a constant term. And it means exactly, it's on there that way because it means the same thing in English. If something is constant, it doesn't change. Right? And a constant in math doesn't change. It has the same value forever. A number that's multiplied to a variable is called a coefficient. Right? And I actually forgot it over there. A number that's multiplied to a variable term is called a coefficient. So, in the example I gave you, 3x squared minus 5y plus 2xy minus x minus 7. And if I look at those pieces, I have 3x squared as a variable term, minus 5y is a variable term, 2xy is a variable term, and minus x is a variable term. Remember, and this is a common mistake, so if you make this mistake, it's not just you, this is a really common thing. The negatives in front are part of the term. So I have to put minus 5y. That's the term, because the minus is attached to the 5. Negative 7 is a constant term. Now, if we think about this, is there ever going to be a case where there's more than one constant term? The answer is no. Why? What would happen if I did have 2 constant terms?
It would be a variable.
That wouldn't be a variable. Like, let's say I put 3x squared minus 5y plus 2xy minus x minus 7 plus 3. Those 2 constant terms. Well, but why do I only say there's going to be 1? What can I do to them as soon as I have to?
You can add them.
I can just combine them. So if there's ever more than one constant term, I'm going to just combine them and say there's only one. So you're only ever going to have one constant term, right? There might be more than one constant term written, but you're only going to end with one. Because not always, with variable terms, sometimes you can't combine them. And as we're going to learn later this week, none of those things can combine. Constant terms can always combine because they're by definition they're numbers. Right? They're things that don't have variables. Now the coefficients of this one is the 3, the minus 5, 2, and I'm putting negative 1 there. When you see minus x, if there is no number there, we're going to assume it's 1. So minus x is technically minus 1x. We just don't write 1 next in front of x because it's redundant. It makes no sense. Right? If you say like, I have a pen, you wouldn't say I have a 1 pen. Right? Doesn't make any sense. Why do you not have to say 1? Because a pen takes care of it. Right, so if I say minus x, that's minus 1x. If I wanted more than 1, then I would say I'm going to take away 2 pens. Right? I'm going to put the number in there. But if I'm going to say I'm going to take away a pen, I don't have to put a number. It's implied that it's 1. Does that make sense? It's the same thing here. If I just say minus x, I'm implying it's just 1. Is that fair enough? All right, do we see the different pieces? So, the other part of forming an expression are what are called factors, right? And it's going to be eventually important for us to tell between the difference between terms and factors. We've already established that if I add and subtract things together, that makes terms. If I multiply things together, that's what are called factors. Certain rules in algebra only work with terms, and certain rules only work with factors. Right, one of the common ones we're going to learn right at the beginning, close to the beginning, is called the distributive property. That only works with terms. It doesn't work with factors. And then there's things like radicals, which you would know as roots, like square root, cube root. Those are only distributable over factors, not terms. So we have to know the difference between them, that way we know what rules work and what don't. So here's an example. All right, I've got 3x squared plus xy. And I want to look at the differences between the different parts of that expression. So the first thing I'm going to do, and I'm going to keep it in blue, each of those, so the things I have in blue, those are terms. And so this expression has 2 terms, 3x squared, xy. Each of those 4 things each term has 2 factors. Now, I don't look at the overall total factors. It's just term 1 has 2 factors, term 2 has 2 factors. It's the number of things being multiplied. I have 3 times x squared, x times y. There's 2 things. The only other thing I have that I can visibly see is that 3 is a coefficient. Right, technically there's 2. What's technically the other one? What's the other coefficient? Technically. 1. Alright, because xy technically has 1.
What's y? That 1 3.
No, xy is 1 term. Okay, it's one thing. Even though there's 2 variables, they are multiplied, so they're just one thing. Alright, so each term can only have 1 coefficient. Because here's the thing, if I put a number in front of y, what technically could I do? If I had 2x 3y, what technically could I do for 3 and 2? Not add, but multiply. I would just say 6xy. It's the same thing as before. It's like, why wouldn't I, if I can't have 2 constant terms, I can't have 2 coefficients in a term. Because that would just come off. It wouldn't make any sense. Do we see the breakdown of the different parts? 2 terms. This term has 2 factors. This term has 2 factors. One of those factors is a coefficient. And in fact, that is another way that we can define a coefficient if it makes more sense in your brain. That factor that's a number is a coefficient. I didn't want to define it that way before because we didn't know what a factor was then. But a factor that's a number is a coefficient. Okay. Do we see kind of the structure of how that works? Now, you can have multiple terms. Each term can have factors. And as it turns out, you'll see in later examples, those factors can also have terms with them. So it's just they can nest in and just, it's kind of like breaking down like a sentence. You have a sentence structure. We have a mathematical sentence structure of term, factor, coefficient, and they all have their uses. When we start learning about combining expressions and simplifying expressions, that terminology will come up. So I just wanted, this is more or less, not really any crazy math yet with expressions, more or less just knowing the terminology and knowing what I mean when I say things. Does that make sense so far? Okay. So here's an example problem I'm going to work through with you, and then the rest of the time is going to be yours to work on the actual problems. So this says I want to list the terms variable and constant, factors and coefficients in this expression. I've got 8x minus 7y plus 9xy minus 5. So I'm going to start by listing the terms. What are my terms? All right, list me the first one. What's the first term? 8x. What else do I got? Minus 7y. What else? 9xy. What's the last one?
Negative 5.
So easy enough to spot. Right? Just everything that's being separated by x there. And each little piece. Now, which ones are variable terms and which one's constant?
Five is a constant.
Everything but 5 is
Correct.
negative.
This is a constant term. All of these are variable terms. Because remember, even though 9xy has two variables, if it even has one, it's a variable term. I could have a term that has 6 variables in it. It's still a variable term because it has multiple. And the only way that it's not a variable term is if it's a number. Fair enough? So I've got this part. Alright, what are my factors in each of the terms? What are my factors here? 8 and x, negative 7 and y, 9x and y, and I don't have any factors of the constant term. Do you see how that breaks down? So technically, these are two factors of this term. These are the factors of that term. These are the factors of that term. You guys have used this terminology before to mean the same thing and didn't even realize it. Like for instance, when I say factors of 10 and you say 5 and 2. Why? Because 5 times 2 is 10. Okay? Those are the things that I multiplied to get the original one. It's the same thing here. I'm multiplying 9x and y together to get 9xy. Just unlike numbers, I can't combine them because
Is,
two are
is
variables.
negative 5 not a factor?
No, because what does it have to do to be a factor?
As the very, or the,
Maxing it.
Um,
And you can go back and look at the notes. What's required to be a factor? Factors are what? Right before it
All
is
the quantities together.
multiplied. What's being multiplied with negative 5? Nothing. So there has to be multiplied to be a factor. Does that make sense? So that's the only reason we don't include it. Constant terms won't have factors as far as expressions go. They do have factors, like 5 times 1 is a factor, but that doesn't help us. And the last thing that I need are coefficients. What are my coefficients?
8, negative 7, and 9.
8, negative 7. The numbers being multiplied to variable expressions, or variable terms. Which again, technically speaking, mathematically speaking, negative 5 is not a coefficient. Why? Why is negative 5 not a coefficient? Doesn't have a variable. It's not multiplied to a variable. Or a set of variables. It's its own thing. Right? Constant things aren't coefficients. So it seems like you guys did it. Does that make sense? Right? You're all answering the questions really well, so it seems like you're catching on. Do we see the structure of an expression? Okay. You've got a couple practice problems and a couple of extra ticket problems. Go ahead and work on those. You can work together. Ask me for help if you're stuck or need to know where to start. You got the rest of the time.